Question 7, a particular machine produces metal rods, normally distributed, with a mean of 210 and standard deviation 6. So I have my mean of 210 and my standard deviation is 6. Mean 210, standard deviation 6. And we're told that a sample of 100 are taken, and the mean of the sample is found to be 211.5. So we're going to be testing 211.5, the mean of this sample, against the mean of the population 210. And we're going to divide by 6 for a one test z-score, but with this standard error of the mean, we're dividing by the square root of n, because it's the sample, so we're going to get 1.5 over 6 over 10, which is 15 over 6, which is 2.5. So let's have a look at our critical region as we mentioned before. So I've got my 0 in the middle. I want to be between plus or minus 1.96 standard deviations to be 95% certain that this is 1. Here's my plus or minus 2. And then we have plus or minus 3. So where does my number come in? My 2.5 is, it's in here between 2 plus 2 and plus 3. So we can say as my z-score is greater than or equal to 2.5, we can reject. And what are we going to reject? The H0 that we're now going to go and set up. H0 mean is unchanged, or mean is 210 centimeters. The alternate hypothesis is that the mean has changed, or the mean not equal to 210. And we can say here that there has been a change. So we can reject H0 because we have gotten a value outside plus or minus 1.96. It's outside this. So we reject H0, reject the null hypothesis that the mean has not changed, and accept H1. Just finish off by saying this. What else did they ask us? Give a p-value for this hypothesis test and interpret this p-value. So let's have a look at the p-value for this score. So our p-value is the sum of the tails. What's in our tail here? So we have my 0, we have my 2.5, and I have my minus 2.5. So we get the value of the tail on the positive side, bring in the tail on the negative side, and we'll see what percentage this plus and minus 2.5 brings in. It's obviously going to be greater than 95% in the middle, and these two are going to add to be less than 5%. So let's look up 2.5 and get 0.9938, z of 0.9938 from the tables. So that means that in the tail we have 0.0062 in there. 1 minus, I'll do it this way, 0.0062 by 2 will tell me what's in the middle. So 1 minus 0.0124. So 1.24% is going to leave 98.76%. So how do we interpret this? So we could write down as 0.9876 is greater than 0.95. We have evidence to suggest that the mean has changed, so we reject H0. So that's all you know. You can say your own version of that, but not much else required. Question 8. The mean mark for all students taking a certain leaving cert higher level subject, 67.5. The mean of my population is 67.5. Standard deviation is 10. Random sample of 100, n is equal to 100 again. And reveal the sample of 69. Has anything changed? We'll do H0 and H1 1 in a minute. We're testing 69. That's our new average of our sample. Does that give us evidence to suggest that the mean has changed from 2013 to 2012, or the other way around? So we're dividing by standard error of the mean, 10 divided by the square root of 100. So we're going to get 2.5 on top, divided by 10 over 10, actually just divided by 1. So again, we're going to get 2.5 for this one. Same answer, 2 questions in a row. It's not the same answer because that's 1.5. Just testing, are you actually awake watching this video? So 1.5, so let's have a look at that. It's within plus or minus 1.96. So we do one sketch like that. Here's my mean, plus 1.5 and minus 1.5. So we can say critical region not breached. Just another way to write it. So we accept H0. So what is H0? Let's go back and write it. H0, mean unchanged. And from doing a sample of 100 and getting an average pretty close to 69, we can say that that is correct. We're going to accept H0. So for H1, the mean is not equal to the 69, or sorry, the 67.5. But we don't have enough evidence to suggest that it's changed using a sample of 100 and finding an average of 69. Z-score for 1.5 is, or Z-score of 1.5 gives, you don't have to write all this out, 0.93329332. So my sketch has got in this tail. Look at the p-value as well if you wanted it, and you can do either one if you're not told a specific way. You can use the p-values here to do your hypothesis testing. So we have 0.7668. So in there you could do it like in percentage. 6.68% times 2 is 136, 12, 13.36%. So therefore not enough evidence, or you could say not, or maybe keep it simple, greater than 5%. Therefore accept H0, and so on. You can expand out if you want a little bit further on that. Question 9, the last one in this video. A random sample of 106 body temperatures. So N is 106. Have a mean of 98.2. That's the sample mean of 98.2. 98.2. So my sample mean. And standard deviation of 0.62. That's what my sample mean. Use a 0.05 level, significance level, to test the claim that the mean body temperature is not 98.6. So we're testing 98.6 here against 98.2. We're testing 98.2 against 98.6. So we got the sample to be 98.2. We're asked, is there evidence to suggest that it's not 98.6? We'll come back and do H1 and H0 in a minute. So I'm going to divide by sigma 0.62 divided by the square root of my sample, 106. So I'm going to get 0.4 minus 0.4 times the square root of 106 over 0.62. And this is going to be, this is 2/3 of 100 and something, so it's going to give me, my calculator's giving me minus 6.64. And if that's correct, that is greater than or equal to minus 1.96. Therefore, we are going to reject H0 in this case. And now you're going to go back and say H0 mean equals, we were testing 98.6. H1, mean not equal to, maybe the colon would be better than the equals, mean not equal to 98.6. So continue on, reject H0, evidence to suggest that the mean is not equal to 98.6, and obviously it's based on this standard deviation here. We'll keep this number really big, 6.64. I've never seen one that big, but it's pretty substantial. Give a p-value for this hypothesis test and interpret the value. Okay, well, we look up 3.09 in the tables, we're going to get 0.999. So kind of we can say that anything greater than that, there can't be more than 0.001 in here. So the max it can be, these two tails at greater than 3.09 is 0.002. And interpreting that p-value, we can say it's a really small number. It's less than the number we're looking for, is for that 5%, 0.05, 0.002. Therefore, reject H0, and whatever way you want to come up with writing the end of these questions, just make sure you write it neatly so it can be seen on the page. That's the end of this video.